Good morning, hello and welcome to the Royal Academy of Engineering's Education and Skills Policy Seminar Series. I'm Rhys Morgan, I'm Director of Education and Engineering at the Academy, and I'm your host for this morning. Regular viewers may notice I'm looking a bit smarter. I've had a shave. Newcomers will just be thinking I was slightly odd. So last week we heard from the Head of Education from the Institute of Physics, Charles Tracy, on a new framework for the curriculum for physics in schools. Charles mentioned that he'd spent the last 30 years worrying about the teaching of the concept of energy in schools. I still maintain that if it's such a problem, let's just stop teaching it, don't bother about it. See, there you go, engineering problem solving right there. But that was last week's topic, and this week we are moving on to another matter. But you can find last week's webinar along with all the other webinars on the Academy's education page on the website. And just a reminder that today's webinar will also be recorded. So let's move on to this week. Now, once we've got over the immediate panic of the coronavirus pandemic, our attention will no doubt return to the fundamental global challenge of climate change. Engineers will no doubt play a central role in addressing climate change and meeting zero carbon emission targets. But are we actually preparing our future generations of engineers and technicians for this challenge? Do we really need to be teaching students Navier-Stokes second order nonlinear partial differential equations for incompressible fluid flow? Come on, really? There's kind of some bitter experience in that message there. You can see it's touched a raw nerve with me. So what should we actually be teaching our students to meet the greatest challenge facing humanity? Well, how do we communicate to students these challenges, and how do we make sure that our engineering curriculum and the teaching and learning approaches prepare them as best we can? This is a subject that my good friend and Academy Fellow, Professor Tim Ibell from the University of Bath, will be talking to us about today. Tim is a leader in innovative structural materials with over 21 years of award-winning civil and structural engineering research. He is currently the Associate Dean of Teaching and Learning in the Department for Engineering and Design at the University of Bath. He's been recognized for his leadership and education in civil engineering with several awards, and was also president of the Institution of Structural Engineers in 2015. Once again, a reminder that we'll be doing a Q&A after Tim's talk, and Tim has promised to be radical and controversial. Now, this is what I like. I want us to turn it into a kind of a talk, sport, radio, chat type thing where people phone in angrily. So do get your comments in on the chat box at the bottom and fire off angry questions to Tim with the Q&A function as well. Okay, enough from me. So, time to hand over to Tim to answer the question, is the climate right for a change in engineering education and training? Tim.
Rhys, thank you very, very much indeed. So before the slides come up on the screen, don't be too angry, please, with your questions, but please do ask them at the end. So I'm presuming that the slides will come up. When they do come up, the first one that you will see will be an image. There you are. It's an image which is taken directly from structuralengineersdeclared.com website, which was set up by Mike Cook. It's effectively a Hippocratic oath. So you sign up to this if you want to do the right thing and not do the wrong thing. And so I thought it was a very good backdrop for the presentation. Gideon, next slide, please. So as Rhys has already warned, parts of what I'm going to say is controversial. So just to give you that warning at the start. Next slide, please. All right. So what I often say to students, well, always say to students, first-year students who arrive at the university, I ask them for their comments on climate change and the climate emergency. And they always shout out very sensible things, whatever it means to them. But there's one word which I am yet to hear a student shout out, and that is, next slide please, war. So to me, the climate emergency, climate change equals war. And I think this is important for each of us to have something in mind when we think of climate change, because otherwise it's just too ethereal. So for me, it's war. Why? Because there are large swathes of land across the world which are presently fertile, but which will become arid. And that will lead to migration of people. Migration always leads to conflict. Conflict always leads to war. That's what we have ahead of us. We have war ahead of us. And I think it's important that whatever the one which is the most important to you as a consequence of climate change, I think it's important for all of us to have this as a focus for us to understand better what it might mean. Next slide, please. So in my own area, construction, it's worth $10 trillion a year, a mind-boggling figure. And if we could somehow monetize the waste which goes on in construction, both at the design stage and at the actual building stage, these sums are colossal. Next slide, please. So just 1% savings, 1% saving is equivalent of $100 billion. That pays for all drug discovery. And we all know, those of us who have anything to do with construction, a 1% savings is negligible in comparison with the savings which are actually possible. So just purely in money terms, it's really important for us to understand the importance of savings. Next slide, please. So one of the things that we've been doing recently, which I'm so proud to be playing a very small part in, is a program grant called UK Fires, led by Cambridge, led by Julian Allwood. And a report was written, primarily authored by Julian, about 6 months ago now, called Absolute Zero. And in a nutshell, this report said it like it is, that we cannot rely on magic to get us to zero carbon by 2050. We cannot rely on technologies which will take an enormously long period of time to implement, based on human experience of implementation of new technologies. We need to be more real. We need to understand what engineering can do for us now with the tools and the knowledge that we have now. Next slide, please. So these are some of the messages, and some of these might terrify you. So the first one is, for some period, we will all stop using airplanes. If we are going to get to zero carbon by 2050, this is a natural, evidence-based consequence of us achieving that without relying on magic technologies. We will also stop eating beef and lamb. In other words, there will be no meat agriculture. And I know that there are researchers in my own university, in fact, looking at the use of the potential for artificial meat production, which could take place instead of this. But meat agriculture needs to end. But the one which is most interesting to me, it might not be most interesting to all, but to me, the most difficult problem is cement. We don't know how to make new buildings at scale without it. So the production of cement makes up somewhere between 5 and 8% of the planet's carbon emissions. That's a big number. And at the moment, we can't do without it. So this report was debated at the House of Lords. And unfortunately, even though it was commended to government, we all know what happened subsequently. And so at the moment, it's on the back burner. It has to re-emerge. Next slide, please. So in other words, what this is saying is that the climate emergency has got to be central to the education of our engineers. We have got to be relying on technologies which engineers need to know now, which can be implemented and can get us to that point. Therefore, it needs to be central. There has never been a more important topic and single-focused concept for the engineering profession than there is right now. Next slide, please. So in time-honored fashion, I asked my family to name any engineers, and they all named dead people. And then I reminded them that I wanted names of people who were living. So next slide, please. They named those two. And I no doubt many people would name those two as engineers. Next slide, please. They don't have engineering degrees. And I do think, I know that there are exceptions. I do think this is important, just as an observation. And what this tells me is that diversity in engineering is absolutely everything. We have got to have diversity. And I'm just saying, obviously. Next slide, please. So one example where diversity is needed is in the next slide, please. We all, I should say all, most of us bemoan a skills gap in engineering. 20% of A-level physics students are female. And I know we had a presentation last week about physics at school. I'm not having a pop at physics at school. That's not what I'm doing. This is a reality statement. 20% of A-level physics students are female. So if we're insisting on physics for entry, for students to study engineering at university, we have an intractable problem. We have a skills gap that we know about and we moan about. And we are simply saying that a large proportion of the population is not welcome in engineering. It is as straightforward as that. I'm sorry, this is dumb. What we are doing is wrong, and we have to change this. And people talk about this and nothing happens. This has to change. Next slide, please. So, in line with this, what would our built environment or our products or our transport systems or societal planning look like had it been designed by any of the following? Had it been designed by pregnant mothers or disabled people or disadvantaged children or the elderly, in other words, in terms of diversity of population, instead of people like me, middle-class, middle-aged white men who all had similar backgrounds and had been educated in similar ways. We cannot pretend for a second that diversity is important and then ignore it both in the intake of students and ignore it in the actions of engineers. Next slide, please. So there are many, many universities around the world that would look at these subjects as being the perfect combination of subjects to enter an engineering degree with. So maths, physics, chemistry, further maths. Next slide, please. And next slide, please. I would contend that that is engineering science. And you can see from the imagery that I'm suggesting that engineering science is an important part. I've put it central in that slide. Excuse me. I've put it central in that slide, but it is a small part of what it is to be an engineer. Next slide, please. There are so many other things which are important in the makeup of an engineer. The best engineers, the fabulous engineers, they have so much more about them than engineering science. And we cannot rely, in my opinion, on serendipity of having these students of engineering coming in without having that broader sense of what it is to be a fabulous engineer about them, rather than just having a focus on engineering science. Next slide, please. So this is a collage of a wonderful colleague of mine, Paul McCombie, who subsequently has just retired, and he gave me permission many years ago to use this. It is simply representing his life. In other words, it's representing life for anybody. That's the idea of this slide. Next slide, please. So as children, we were all interested in everything, and that's what this collage is intended to represent. Next slide, please. And then we went to school, and things were divvied up into subjects, and we had to learn the subjects, and we were examined in subjects. Next slide, please. And then we were told, I certainly was told this, I'm good at that, I'm lousy at that, give up the things you're lousy at, do the things you're good at. Next slide, please. Then we did A-levels. Next slide. And then we went to university. And you can see from the imagery, next slide, please. You can see from the imagery what's going wrong. And I am a firm believer that this is what's going wrong. We view academic excellence as being narrow. We treat that as being something quite special. And I think it is the absolute reverse of that. So on the right-hand side of the screen, wouldn't it be wonderful if education was broad? Wouldn't it be wonderful if our engineering students, wherever they are in the world, continually had a smile on their face, and they were exploratory in their education, and they had fun, and they were doing creative things, and they didn't have the whole worries of the world on their shoulders about handing in 6 assignments next Monday morning. Why can't we do this? Well, we have to do this, and in the process at the bottom, discover real academic excellence. And an example of that, one example, a very simple parochial example for me, is a few years back, a student walked into my office, first semester of first year. I'd given them, I think, quite an interesting design project to do, covering hundreds of square meters, with a timber structure over Glastonbury. And he came back to me and he said, I've been online, I've had a look at shell buckling, I've taught myself about eigenvalues and eigenvectors. I think it won't buckle, but what do you think? And this is first semester of first year structural engineering student. And for those of you in the know, usually shell buckling is considered to be a specialist MSc topic. This is the point. When students are exploring things, they will learn whatever they think they need to learn for themselves, and they will discover the important things for themselves. Next slide, please. So I believe that education should be broad, it should be creative, and it should be fun. Next slide. And that is how we get deep learning. I do not believe the other way around is possible. And it is the other way around, which is usually the model which universities use. Universities usually go for the deep learning while you're here. 4 years only, we need to give you the deep learning. I don't believe in that. I believe that education should be broad, it should be creative. And that is how each individual student will grow their downward roots, because they will be inspired to grow the roots of that deep learning in any area which they think is most appropriate to them, not what the university thinks is most appropriate to every student in the class. So I believe that we should be creating our T-shaped students while at university by giving them a broad education which leads to deep learning. And then when we have that, we have a T-shape, rather than to be providing the deep learning and then saying to students, when you graduate, that's when you start having fun, and that's when you create your broad T-shaped. We've given that option too much of a shot, decades and decades and decades, and we have problems. I think we should give something else a shot. Next slide, please. That is when we get our societal-based challenges being central to education. When we have that T-shaped person, that is when society becomes central to the roles of an engineer. Next slide. So this might seem completely off the wall. What makes a gold medalist a gold medalist? What do I mean? Well, all of us, we walk into professional engineering institutions all the time, and we see the great big wooden boards with the gold writing everywhere and the names of the gold medalists in each of our disciplines. And they're fabulous names, all of us. We look at them with a complete reverence. And then you say to yourself, well, what makes a gold medalist a gold medalist? Why are their names up there? Is it because they're fabulous at STEM? Is it because they're fabulous in terms of mechanics of some sort? Partially, of course, yes. But there are thousands and thousands of people across the world who have those similar skills. The difference between them being on those boards and those who are not on those boards, in my opinion, is creativity. They've done something really rather special and creative with their skills and with their talents. They've done this. And that is why they're on those boards. And therefore, we revere creativity implicitly in our profession. And we revere it. We put these names up on gold boards. Next slide, please. So where is creativity in our undergraduate curriculum? If we revere creativity, where on earth is it? How can we possibly lead in the climate emergency without creativity? But the most poignant question is the bottom one. How many times have you come across in a university learning outcomes which explicitly say the learning outcome for this particular unit or this particular module is creativity, and it will be assessed in the following way? How often do we come across this? And yet the entire profession reveres creativity. Next slide, please. Okay, so the other part of being an engineer, of course, is to have ideas. We're paid to have ideas. This should be part of our education. It is a skill, it is not a talent. We have people who, a person called Oliver Broadbent comes in, talks to our students about how to have ideas. I have my best ideas 8 o'clock in the morning with a cup of tea talking to 2 other people. I know that about myself. I've learned that. Well, students need to know that about themselves. They need to understand how to have better and better ideas. And these are skills. They are taught skills. And we need then to allow them to understand that that is a divergent thought process. And then we need to give them tools for convergent thought processes to prioritize these ideas. Students need to understand the difference between these two phases in an accelerated manner. So as I said at the bottom, presently we rely on osmotic serendipitous magic in design projects. I'm sure I'm right in this. We say to students, here you are, here's a design project, go and work in a group together. And we'll see you in 8 weeks' time. We'll talk to you from time to time, but we'll see you in 8 weeks' time. Get on with it. We don't give them the tools. We don't talk about how to have ideas, how to prioritize ideas, how to work in a group. All of the issues associated with real education, to be real engineers, to have the skills to do the things which engineers need. Next slide, please. So why is it important? Well, this is, I think, a reason why it's important. On the horizontal axis, we have time, and on the vertical axis, influence on the success of a project. So in other words, at the origin, an engineer and his or her team meet with a client, and the client gives them a brief, and they then jump on a train, go back to where they've come from. And in those first few hours, the huge decisions are being taken, the really important big concept ones, based on asking the right questions. The people involved on that train journey, they are asking each other the right questions, and the influence and the success is gigantic. Right, next slide, please. Universities focus in that zone. They focus on the detailed sums and sizing, and I'm not suggesting for even a second that that is unimportant. It is crucial. I teach that myself. It is crucial. So important that that zone is covered in an engineering education, obviously. But next slide, please. There is huge scope for us to be doing at least the same amount of time in the more vertical zone, the bit which actually defines what it is to be a chartered engineer and to be able to take decisions quickly. And for students to understand that it's asking the questions, is not answering them, it's asking the questions. And what those questions are, which is so important to the success of a project, and collaboration and understanding ethics and society and all these things, which are rarely the value in being an engineer in the vertical zone. These need to be part of the engineering education process. Next slide, please. So how do we actually make net zero carbon things? This is a slight aside, but it's got a purpose coming in a slide or two. How do we actually make net zero carbon things? Well, engineers need to know. They need to know now. They need to understand, to repeat myself, what the questions are in order to get us to net zero carbon things and how everything ties together. These are the really important bits. Next slide, please. They need to lead. This is the crucial thing. At the moment, if they can't answer, if they don't know what these tools are and they don't know how to enact these tools, then they can't possibly lead in decision making. This is the issue. Next slide, please. So what about having some real learning outcomes which are fit for 2020? So here's something quite controversial. We've just had the AHEP Learning Outcome Review. Frankly, I'm going to be blunt with my commentary. It's tweaking around the edges of 1970s learning outcomes. We could have written these learning outcomes 50 years ago and tweaked around the edges. And that's what we have. That's what we deserve because it's what we've got. Well, come on. We need learning outcomes which are fit for our present circumstance. So what I'm about to show you in the next slide is a whole series of learning outcomes, which you'll see that the font is quite small because there are lots of them. And it's a list which I've scribbled out not many years ago, probably 2 years ago now, on a train journey from London back to Bath in about 15 minutes because I was so fed up at a meeting I'd just been to where we had been talking drivel, frankly, about learning outcomes. And I wanted to make the point that we need to revamp our learning outcomes. So next slide, please. So what about something like this? ILOs, that means intended learning outcomes. So a mindset to temporarily borrow as little material as possible. So temporarily borrow as little material as possible. A mindset to design for cradle to cradle. Creativity as an assessed skill. An ability to ask the right questions. In other words, an ability for us as academics to assess the questions of students rather than just assess the answers of students. A confidence and an empowerment to enact change. In other words, a graduate going into a company in 3 weeks into the job saying to the boss, I'm not going to do that. I refuse to do that. I have signed a Hippocratic oath, as have you. I am not going to do that. Confidence, empowerment, an understanding of how to lead change, an ability to collaborate, to add value. I always talk about being covered in Velcro. A motivated learner for life. I see so much hand waving in universities about we're producing learners for life. We're producing learners who can learn. show me the evidence. Show me the evidence. I see the hand waving. I often do not see the evidence. A worldliness, an understanding of how we fit in. Two types of empathy. The first one I've talked about already in terms of diversity. The second one is our near total first world emphasis in the UK on engineering education. Is it appropriate? Of course it's not appropriate. We have a global issue. We have two global issues right now. I'm talking about climate emergency. It is a global issue. We cannot continue to have an education process which is colonial in outlook. Digitally proficient, goes without saying. Climate emergency driven, goes without saying. Why and how engineers can benefit societies all over the world in all sorts of ways, that ties back to the worldliness. An ability to have ideas, I've talked about that, an ability to prioritize those ideas, convergent thinking, an ability to approximate, to question software, to properly model physical problems, not to be hung up in the derivations of software, not to be hung up in this. This is beyond that era, to be questioning software, to be questioning modeling, to be dissecting a brief, to be writing a brief from scratch, to be sketching to communicate, sketching to develop ideas. Things which, in my opinion, these are too important for words in terms of those first few hours where we have the biggest influence on decisions being taken in big projects. And a willingness and an ability to teach others. This is, again, too important for words. Mentoring used to be top down 30 years ago. Mentoring is now at least as much bottom up. Companies are taking youngsters and expecting them to mentor upwards in terms of various digital skills in particular. Therefore, our graduates need to understand how to do that. It must be part of their education. And the bottom one, and I really do mean this most importantly, and it's not really a learning outcome, but it is an outcome which is for our graduates to enter the profession. They've got to want to enter the profession. There will always be a few exceptions, clearly, and I'm not worried about that. I'm worried about the vast majority needing to enter our profession on graduation, because if they're not entering, something horrible has gone wrong. We've taken really inspired and motivated learners, and we have done something wrong with them if those learning outcomes above have not been embedded. Next slide, please. So remember that list. So does that learning outcomes list really require maths, physics, further maths, and chemistry as the background for our engineers? What I am not asking is, are these subjects not relevant? Of course, they are relevant. Do we need every engineering student to have those subjects as the basis for them to go on for those learning outcomes? Next slide, please. No, just no. And I don't even think this is controversial. This is just no. We do not require that. We have got to have more breadth. Yes, we need to include subsets of those subjects in our requirements and in our offering and in everything we talk about. Of course we do. I'm never pretending that. I never would pretend that we don't. But to have that as the exclusive list of subjects for students to become fabulous engineers, we have got it wrong. Next slide, please. So this is a review which was commissioned by the American Society of Civil Engineers. They asked the Carnegie Foundation to do this. And the Carnegie Foundation came up with these comments, which you might find reflect quite neatly some of the issues that we come across in the UK. So I'll read them out. The majority of four-year courses are taught as 2 years of science and 2 years of application. That theory and practice should be taught simultaneously. Examinations as assessment are not connected to teaching. Fields of application are expanding, but teaching is not keeping up. Engineering courses have high dropout rates on graduation. That's the point I was just making. And there is poor correlation between, there's a message on my screen, so I can't read it temporarily. There is a poor correlation between, until the message disappears, I can't read it, examination grades and the quality of graduate work. Okay, now that last point is a point which gets made often in the UK by various people. So, recognize those. Next slide, please. That was written 102 years ago. 102 years ago. Next slide, please. There's the report if you're interested. What on earth have we done in 102 years? Next slide, please. So we need an outcome. We need to define things. So the outcome is this. Student A, student B are identical twins. Student A joins an engineering company at age 18. Student B goes to university. 4 years later, 10 years later, 20 years later, you make up your mind, whatever time frame you have in mind. What head start does B have on A? In other words, the student who went to university, because there better be a head start. Otherwise, why go to university? There must be a head start. We need to articulate that head start. We need to deliver that head start. And I'll repeat something I said earlier. I see so much hand waving in universities about the worth of an engineering education. I want to see the evidence for that hand waving. We need to articulate what this is. Next slide, please. So I ask a question of my students. The question I ask is the following. Next slide, please. When your children ask you what you did to reduce carbon or to mitigate the climate emergency more generally, what will you say? And I think it is our job. You can ask any questions you like. That's my one, which I ask, because it focuses my mind on what I need to help my students with in their own, on a human scale, completely human scale. What am I trying to help them with in terms of them being able to look their children in the eye? That's how I do it in my mind. And I think from my perspective, this is a positive way to engage. Next slide, please. And finally, every year across our education system, we have 650,000 students going from year to year to year. And in the final 2 years of study, 30,000 of those students choose both maths and physics in their final 2 years. So is it really appropriate for us to be choosing from our pool of engineering talent for the future to solve all of the global challenges that we have? Is it really appropriate for us in this country to be choosing from 30,000 and not to be choosing from 650,000? Nobody can tell me that amongst the other 620,000, we don't have the most fabulous budding engineers who will be able to undertake and engage with those learning outcomes that I was talking about earlier, which are at the heart, I think, of the climate emergency. So next slide, please. My comment is there's more to a flower than a stem. Next slide, please. So thank you very much for listening. I know that was controversial. If you're cross, I apologize, but please do ask questions. I'm very, very happy to engage. Thank you very much.
Am I on? Can you see
You're
me?
on.
Tim, I am livid. I am furious. Thank you very much. That was excellent. Lots of chat going on the sidebar. And very early on, an important chat about the future of Welsh lamb, which I am assured the Hills of Wales have got for nothing better than just growing Welsh lamb. They can't grow anything else on them, so we're okay there. But lots to talk about and lots of very interesting comments and questions coming through already. But I want to start off, one of the things I didn't mention, very important omission actually from me right at the outset, was your current role as the chair of JBM, the Joint Board of Moderators, which is the accrediting body of the institutions involved in the built environment. So the Institute of Civil Engineers, Structural Engineers, I believe the Building Service Engineers.
Chartered Institution of Highways and Transportation and the Institute of Highway Engineers.
Yes, great. So, so I put it to you, Tim, that universities requiring physics on entry are only responding to the pressures that you are putting on them as the accrediting body. Now, they don't want to take on students who are going to fail their university degrees. They will also be punished by the Office for Students for doing that. So they're under pressure to make sure that their students get through an accredited degree. You as the accrediting body are putting in this huge amount of physics and maths at very, very high levels that are causing them to react to that pressure. Now they tell me that, the universities tell me that they want to change their curriculum, they want to be innovative, they want to try new approaches, but these are high stakes accreditation visits, and if they don't have the right level of maths, the right level of science in them, then actually all they're going to do is not get accredited, and that means they won't have the students coming to them.
Thank you, Reece. Okay, first thing, there have been significant changes in both the maths and the physics curriculum over the years. One of the issues we have is of universities not keeping up with those changes. And so I think most universities, and I say this advisedly, most university admissions tutors think that what was covered in physics when they went through the curriculum is still covered in physics. And there is a big gap in my experience when people actually start talking about what they think is involved. That's the first point. Second point is, there have been changes to the maths curriculum, and the maths curriculum, that might surprise many people, it shouldn't, but it might, that Newton's laws are all covered in the maths curriculum, and everybody needs to cover that now. So gone are the days of choosing your modules. So these are points which are really important to understand, that in fact, if universities kept up more closely with the changes in the A-level curriculum and in international baccalaureate, they would feel for themselves the scope for the flexibility which they have. But on top of that, the real point here, which I think you're making, is there's a whole bunch of stuff which needs to be covered in an engineering curriculum, and surely our students need the right background. Yes, they need the right background, but they don't need the exclusive background for that. So, you know, there's no doubt in my mind that teaching something, the comment which I always make, which I'll make now, is that to me, if you want to try and instill in a student the basics of calculus, for instance, and it's a student who is terribly bright, and it is a student who has a broad background and is open-minded, that will take me less than a week to do. If you give me a narrow-minded student who's focused only on a set of narrow things, and I talk to them about the holistic importance of global challenge, it would take me a lifetime to get across to that student. And to me, that's the big difference. It's what we choose in universities as the priority for what it is to be an engineer. And the accrediting bodies are not prescriptive in that choice of priority. We are not.
Sure, but you know, the universities will tell me that you know that you are requiring 3 years of geotechnics, 3 years of hydraulics, 3 years of structural, 3 years of materials, and they're just saying we haven't got the space to do those other things. So what's got to give? Something's got to give here.
So all that's required is threads. So in our particular accrediting body, we ask for threads. And so what we're saying, I can't remember the exact proportions. I should know, shouldn't I? But I can't remember what they are. They are relatively low numbers, significantly less than 50% of the amount of time which we require on technical things which we think are important in civil and structural engineering. The rest of the time is a complete freedom, total freedom to do whatever a university degree wants to do.
How about this as an idea? Let's just get rid of accreditation. Nobody bothers to get chartered anyway. Why bother?
You know, in a different life, I said the same thing. And over the years, I've been drawn to the idea that accreditation is important. But in a previous existence, I thought that we should scrap it.
Okay.
The reason why the reason why I have become more keen on the idea, or keener on the idea, of accreditation is not to ensure that students all have the same basic level or any of that. It's to have those discussions with universities. It's to have a body which sits down with a university and says, are you actually doing all you can possibly do with your students? And to me, that's the most important part of accreditation. It is not a police force. It is a social network, in my opinion.
Okay, we'll move on from accreditation because we can carry on for ages on that. I was really fascinated by your comment very early on around waste in the design process in particular, you know, those early phases of design, and we don't spend enough time teaching students of engineering around those early phases of design. And it got me thinking, I mean, this is, you know, very often that, you know, this is a multidisciplinary problem. And if we take the construction sector, because that's your background, you know, we very often hear that clients will engage an architect, but they won't ask to engage a structural engineer. They won't ask to engage a building service engineer. So the architect will come up with some fancy design and hand it to you, and then you will do your design. You know, you'll work out the relevant kind of structures to do that, but you don't really engage with the building service engineer. And so actually they'll then say, well, hold on, we've got nowhere to place our ventilation systems, or, and then further down the line, you won't engage with the fire engineer. And so they say, well, there's no firewalls in here, so we're going to have to put sprinkler systems in, and the architect gets across. So, I mean, to what extent do we need to really be rethinking the whole multidisciplinary nature of engineering when we teach civil engineering, mechanical, electronics, and so on?
Okay, so you're definitely asking the wrong person here, Reese. I represent a Department of Architecture and Civil Engineering, and it's the basis of the entire existence of the University of Bath Department. So you're definitely asking the wrong person. Ask other people, because the spirit of what you're asking, I think, is completely and utterly central to where the profession needs to move. It's collaborative, covered in Velcro. This is exactly the type of graduate that we need. We do not need graduates who understand all of those things. We need graduates who understand their own area and understand how to exploit the areas of the other disciplines, and how to work with those other disciplines to produce the sorts of designs you're after. But to go back to waste for a second, Reese, if I may, the waste that we're talking about is extraordinary. It happens on all kinds of levels. It happens on, this is purely from just purely structural engineering design side of things. We know from a survey that we did that our the structural engineers in practice are deliberately putting fat into their design, the sleep at night factor into their designs. We know then that the strength of concrete, strength of steel, or you name it, is always overspecified. It then arrives on site overspecified again in case the contractor gets it wrong and they need to chop things down. It then hardens over time, and 20 years later we've got twice the strength that we expected at the start. The waste and loading in buildings. We talk about loadings being 5 kilonewtons per square meter. The average loading in the building is less than half a kilonewton per square meter, and yet we design it for 5. There are so many areas, one after the other, where waste takes place, and we have got to cut through that, and it's got to be part of the education process.
Okay, very good. We're getting lots of questions in, so I'm going to turn now to some of our questions. We'll start with Pam Dugdale, who was very chatty on the chat box during the talk with Peter Goodhue and various others. Pam asks, do you think that we should embed sustainability throughout an engineering course, or have a separate sustainability module? I think I know the answer to this. And how do you prepare? Most importantly, I think, is the second part of the question. So how do you prepare and support very often reluctant teaching staff to embed sustainability and zero carbon in their lessons or labs? Okay, so answer the first question, as you might expect, it's got to be central. We're in a new era. We're just not even in the 2000s. We're in 2020s. It's a new era. Climate emergency is the thing to tackle. We used to say as kids, when I went through university, used to say, an engineer can do with a penny what anybody else can do with a pound. Well, it's changed now. What about talking about carbon? With an engineer can do with 1 gram of carbon what anybody else can do with a kilogram of carbon. It's a new era. And so it's got to be absolutely essential. I'm using carbon, forgive me, that's too parochial. It's much broader than that. It's the entire concept of circular economy, regenerative design, societal global challenge, which it has to be at the heart of education. There are no bolt-on modules. This is just central. How do we bring people along who aren't engaged with this? Sack them. They should not be educating our engineers. If this is not what they think is important, then they are wrong. Okay, so I'm gonna challenge you on that, because of course our university kind of measures are not on teaching. I mean, recently the TEF has come in, but I mean, largely it's still about the research income that you provide, the number of journal publications you produce. That's what you're measured as an academic. So until we change the very nature, the very structure of how we recognize academics in universities, then it's unfair to say that you have to focus on the teaching.
Point very well made, Reese. What I would say is that if we have researchers in universities who are using public funds to do research at the moment, which does not aim at 21st century global challenges, then we are not spending our money wisely in research in UKRI and in other bodies. In other words, the academics who are engaged in that sort of activity by definition will have an interest, and therefore they would not fall into the category. So the only people who would fall into the category of not having an interest are those who are doing research which frankly should not be funded, because it is not dealing with global challenges, and it should therefore not be funded, and therefore there should be no position available for those people.
Okay, I like it. This is the kind of, come on, I want someone to phone in and get angry. If only we had phone calls with this. Okay, I'm going to move on to your learning outcomes, which there was lots of comments on in the box. Many people agreeing with these, and actually, you know, why aren't we starting these in school? And in fact, we may very well be looking at that. But Beverly Gibbs asks, is the barrier really learning outcomes, or is it assessment? You can't innovate learning outcomes without being prepared to innovate those assessment modes as well.
Agreed. I thoroughly agree with that. So assessment needs to drive education and vice versa, and it needs to be cherry-picked. At the moment, it's just a free-for-all. We mercilessly over-assess our students, all of us. We just do mercilessly. It's not necessary. It's simply not necessary, and it needs to be part and parcel of as it were the revolution, is because it's such an important question, such an important point. It's also the type of assessment. I'm frankly, I was talking earlier about the importance of assessing the right answers, and just before we started this, Reese, you and I and others were talking about the idea of how am I going to put it? I've lost my thread. Forgive me, I've lost my thread. It will come back to me. It's to do with the importance of assessment, but it will come back to me.
Okay, no worries. It'll come.
I've got it. Sorry.
Oh,
it's the difference between outputs and outcomes. The difference between outputs and outcomes. We assess outputs. We should assess outcomes. That's what we should be doing. And we should be relying on our students to be doing things which actually have some form of societal benefit. And so in other words, producing a web page as an output for something is not good enough. Producing something such as a web page which leads to some form of impact in society, that's an outcome. That would charge our students up. It really, really would. Is a big difference between those two, and we could be using our assessment so much more positively.
Yeah. So I started something off by talking about the JBM on the questions. You might be surprised. Paul Jowett says JBM not prescriptive. So Dan Maskell from Bath. Do you know Dan?
I know Dan very well.
Dan asks, well, come on, Tim. He doesn't say this, but I'm saying this. Come on, Tim. You're the chair of JBM. Can't you be more prescriptive? Why don't you make the changes? So why don't, it's down to you, the accrediting body, to say, why not invest in a new professional profile, Chris Eady asks, to deliver your intended learning outcomes? Why don't you put those in the accreditation process?
So there is a working group right now on JBN, which I am chairing, and we are looking to embed new learning outcomes which sit on top of AHAB. And the flavor of the learning outcomes, you will not be surprised to learn, will be the flavor of the sorts of things I was talking about earlier. That's the first point.
And can you, oh, sorry, go on.
No, you go ahead. You go ahead.
You go first, because my question was, can we extend this to the other professional bodies? So it's not just about the built environment and civil engineering courses, but actually right across. So engaging the Engineering Council in these broader intended learning outcomes.
I would love to do that. I would love to do that. So I'm going to start in an area where I know best, and if others would like to have discussions and take that sort of idea forward, I'd love to have that. I'd love to have that taken forward. But I'm going to say something which might annoy some people. Forgive me if it does, but I often hear universities say that the JBM is prescriptive. I'm sorry, but it's not. It is not. Universities often choose their words to imply that they are being prescriptive, and they use it as an excuse. And that is, I see that time and time and time again, where they're using things and they're saying things which are simply not true. They might have been true in the past. They're not true in 2020. And it makes me cross when I see it, because it's being used as an excuse for lack of change when actually there is freedom for change.
So it's all the academics' fault. I knew this. I knew it. I knew it from the outset of this talk. I knew it's all those lecturers to blame. What do you think about that, folks? Okay. This is a really interesting question. So going back down the age range, 2 schools, Campbell Middleton asks, wouldn't a good start be to move away from this narrow 3 subject A levels to a broader education along the lines of a baccalaureate, which contains a mix of STEM and humanities?
Yes. So it's just a personal comment. I did the International Baccalaureate. I did 7 subjects, 4 of them were languages. And if anybody had ever said to me, you have to just choose 3 subjects to do A levels, and your 3 subjects need to be the 3 science-based STEM subjects, and I had to give up my 4 languages, I would have collapsed in a heap, because it was the bit which I really enjoyed at school. I was good at maths, but I loved languages, and it just would have been wrong. So a very personal experience in answering the question is, yes, we need a much broader education. But I don't like to pick my wars. I'd much rather pick battles. We can fight battles. Fighting a war is trickier.
That is a big war to fight. But the Royal Society are working on that one for us. So thank you, Royal Society. But what do we think about maths? So Nick Russell asks, we do need it as knowledge, but maybe not at A-level, but maybe we do. So your student who talked about non-linear failure modes of his structure, ultimately someone has to be responsible for that bridge not falling down. And so we do need that level of mathematics, that level of competency or ability to be able to deal with that kind of stuff.
Yeah, of course we do. Yeah, of course we do. There's no question, we do. What I am much more interested in is not at what level the math's in or anything like that. That's not what I'm interested in. What I'm interested in is if a student is scared of maths, they cannot and must not ever be an engineer. Must not, if they're scared of maths. If they are perfectly comfortable with mathematics, perfectly comfortable, but they prefer other things, they could go on to be a fabulous engineer. That is my point. So no, I'm never ever going to pretend for a second, and I don't want this to come across, that maths is less important. It is crucially important to being an engineer, but there are other things too. As long as somebody is not scared of maths and they're willing to learn, that is fine.
Great, thank you very much. I am thinking that maybe we need to have another session with someone from the Engineering Council, who are the chair of the accrediting committee or whatever it is, and maybe an academic to really fight this one out, because I think this is really important. I think, and of course the Academy is very much engaged with this debate as well. But Tim, thank you so much for a really stimulating talk, and radical and controversial it was indeed, and I hope our viewers enjoyed it. I also want to thank you for a great Q&A and some really good questions from the audience as well. Tim, I might ask you also to inspect the quality of my daughter's treehouse that I've built. I'm slightly worried about non-linear buckling failure modes. I can assure you that I've not considered any eigenvalues or vectors in the design of it. I'm slightly nervous, so I'll be in touch separately. Okay, thank you very much. Next week, we have Tom's Ravenscroft, the founder and CEO of the Skills Builder Partnership. And actually, he might be presenting some of the information, some of the kind of learning outcomes that Tim's been talking about there in the school system. Well, at least I hope we do. We've asked him. I don't think we've had a response yet. So he might not know it yet, but we're hoping that he'll be on the talk next week. If he does come, he'll be talking about the embedding of teaching of skills in the curriculum in schools through the new universal skills framework that he's developed, which is getting a lot of publicity in schools and a lot of take up, or at least it was before the coronavirus happened. So keep an eye on timings for that, because we haven't confirmed exactly what time we have, so we may have to shift things around to fit his availability. But please do join us next week. And until then, bye for now. Thank you.